no, not really, not that kind. It's a suite, a software suite. So that's the first thing to understand, and it operates like one. There are a few separate components that can interoperate with each other, but it does feel like you're using a few different programs that are coordinated and work together. So, in my opinion, much more than, say, like LibreOffice is a suite. That's a collection of separate programs you might use for something that each for its own purpose can cross over, but no. KiCad is a lot more integrated, so yay. It actually is like candy, because you get all these different things that play nice together. So covering what does it mean that KiCad is a software suite? Well, as it describes on its homepage, KiCad EDA is its full name, is a cross-platform open source electronics design automation suite. So if those words mean something to you, good. You're ahead of the game. If you're not familiar, that's fine, but what it is, it's cross-platform is one of the key things I like. So I can jump from my Linux box, I can reboot into Windows, pull it up on a Mac, I can run it everywhere. Plus, they also have Docker, which is mainly intended for command line integration kind of stuff, but if you wanted to deploy something to the cloud that does some of these operations, they have a Docker image for you. So it's Windows, Mac, Linux, and cloud. If you know how to do that, you'll appreciate that. Now, first, I need to do a public service announcement. For my personal recommendation, don't get COVID. Because I had a problem. At the beginning of the year, beginning of January, I was like, okay, time to dig in, check the current state of everything, get some actually PCBs manufactured, get stuff out. I got COVID. And it made me stupid. For work, day job, took a while to recover. So try not to do that. Unfortunately, that disrupted my planned cycle to have physical manufactured PCBs in hand. However, that aspect of it, I think, is so well proven nowadays. Just go on to YouTube and you'll see you can find all sorts of people who have made PCBs and had the manufacturers from a service bureau with KiCad. But yeah, I don't recommend COVID. Okay, moving on. So the main points is we're going to have two main steps, is how I've summarized it. And there are two main concepts. Get those down, and it's simple. Everything else is just details. If you take a simplistic view. So the two main steps when working with KiCad, you're going to be working with a schematic and working with PCB, so the PCB layout. Two separate steps. You don't have to. For example, if you're just somebody who wants to record their arduino projects or breadboarding or anything like that, like even mini breadboarding, that's one of the things I did with KiCad a whole lot. I'd throw a breadboard layout in, put my components, save it that way, export it so that I had a record of what I had designed. Never went to PCB manufacturer. You don't have to. But if you want to, it makes it easy, especially in recent years. It's gotten so much better. Going along with that, we have two main concepts. You have the symbol and the footprint. So who's familiar with those terms in this context? Maybe a quarter of you. So not bad. I was hoping this was useful information. For those of you who know it, you already know it. For everyone else, it's new. So in general, that's what you need to know about to use KiCad. You're going to make schematics, you're going to maybe lay out a PCB, you're going to use symbols on the schematic, and you're going to place via footprints on the PCB. Kind of simple, right? Is it simple enough for me to try this at a conference? Live? Sure, why not? Because for me, I could give static screenshots, pre-canned things, but that doesn't convey the product itself. So let's try to run a live demo. So now, oh good, I am mirrored. So we see there are a few KiCad programs in here, but this one right here, the blue, is your main entry point. And I prepared some things in case this goes wildly wrong. I should have something to show at least. But let's say I'm going to start a new project. And scale live, yay. So first of all, can everyone see this? Okay. It's a little bit dim and a little bit smaller, but I'm going to, the positionings where things are. First of all, you go to make a project. There's a few icons along the side here. Now, first and foremost, look to the help menu. Not sure if you can see it up here. It's a little bright in the room. But the second item here, getting started with KiCad. A whole bunch of things come up. So what this does is bring you to a local file version of their pages. And in it, it walks you through all the basics of all this, of a tutorial. So start with this. If you're unfamiliar, start with getting started in KiCad, which is second item here in the help menu. It's actually helpful. Now, if not, I'll go through and try to actually do that now, roughly, and kind of explore a little of this as we're going, what's it going to do in all this for you. So first of all, we have these two sections are created, these two files in the project. It's project-oriented. It's going to do it in a folder. So it's going to do a schematic file and a PCB file. So let's double-click on the schematic. Here it is. Most of the tutorials say to fill in the information on your project first, so when you open this, you get the title and company. And if you're a CAD person, if you're used to doing this kind of thing, company's important. You're used to all that information. If not, you don't have to do it. Ignore it. Then the essence here, we have a few empty trees, lots of tools and options, and placing. Place is one of the menu items. Place is where you're going to probably get started. And if you notice, if you can see in the menu, if not, I will tell you, a lot, like all of the top items have a single letter hot link right after them. So you can do these things, wires, buses, symbols. But let's just start with a symbol. Now, one of the warnings though, would the very first time you bring up KiCad, it may have nothing, no symbols, no PCB footprints. It's going to need libraries of those. You can get libraries two main places, three. One, from KiCad themselves. The project makes things available, so the first time you pull it up, it's going to ask you as a default, grab these libraries and tell it yes, and it will get you a default set of libraries. Two, you can get them from manufacturers. People who make components, people who sell components, a lot of them will have these library files available, because if you pull their library assets into your program and you design with their components, you might buy their components. So it's a win-win there. And also the manufacturers. So there are service bureaus who you can send your plans off to, and they will manufacture your PCBs and send them back to you. I mean, back when I got started, you had to do copper boards, black marker, etch it with acid, try not to spill dangerous liquids, all that stuff. No more. Now you just send it off, it comes in the mail, just like Amazon, nice and easy. So they often, too, will have symbol libraries, footprint libraries, others available. So that's the second source is from the vendors. Third source is just open source. It's open source kind of thing. Is anybody might put something out. There's a lot of small libraries up on GitHub and GitLab and other places like that. So you can go and get your symbols. Then once you get them, now you're set. You have your libraries populated. So what can you do? I'm going to hit the A key. And if you did not see, there was a brief pop-up where it said loading symbol libraries. Let me try to mess with my system while it's running. To see if it's a modern computer. There, is this any more legible? Good, okay. So always depends on the projector and the lighting in the room and everything, which one works better. But here, let me hit escape to cancel it. Oh, I have something there. Let me hit escape again. You see the cursor has a little symbol attached to the cursor. I hit escape, it doesn't anymore. Okay, go back to A, because it wanted me to place something. Okay, I'm going to design a circuit. First question I have, it needs power. How's it going to use power? Am I going to plug it in, or am I going to use a battery? Let's see battery. So I'm in the search window at the top. I tap B8, there we go. A couple of options for batteries. I'll go battery cell, maybe. And then down, there are other options, and this just pulls me into the middle with the most likely candidates. So I'll go to battery. Oh, that's tiny. I can't see anything. What do? Go over to it. If you have a mouse, scroll with the mouse wheel. That'll zoom in and out. There. That's a battery. Now I can see that's a battery, right? Okay. And then I'm moving it around by middle clicking. So I'm clicking my scroll wheel on my mouse. Or I could right click. So zoom in and out, scroll around. That's going to be how I'm navigating, at least. You can do keyboard if that's your thing. But those are the main navigation things here. Zoom in and out. So zoom out, get to where you want, zoom in. I could look at the title and the file, but I don't care. So let me come back to what I'm doing here. I got a battery. What am I going to do next? So if I click again, it's going to do the last action, which is the A key I typed before. I didn't have to type this time because it's still in that mode to add a symbol. I don't want a battery. I already have a battery. What do I need? LED. Ooh, and look, there's basic LED, and then all these others, series, pads, RGB in a 6-pin package. Ooh, that's fancy. So you do have, as soon as you've got the default symbol library, which you want to let it bring in on startup, you have a lot of options. Nowadays, that's a big thing. Even like 5 years ago, it was a lot harder. You had to design a lot of your own footprints and symbols. Now, either they're already in the library or they're easy to download. So let me just go with the basic LED for now. Say, okay, I put an LED here. Make that a little bigger. Anyone in the back able to see that symbol at least? Okay, at least somebody can see it, good. So then, if I hit escape, I'm not placing things anymore. the cursor changes. I can draw a wire by hitting W. I hit escape. So if I hit W, it starts doing the operation. If I hit escape, it cancels the operation, but if you notice, my cursor stays in this green line mode. So it's still in that mode, so I can do more stuff if I want. Otherwise, I can hit escape to cancel again. But in addition, components will have this little circle at the end, and if you see, when I move over to the circle, it changes into that wire symbol. So if I just move to the circle, click, now I'm making a wire. Yay. That's how you do a circuit, right? And, oh, I don't like this. This LED is not in the right place. How can I fix that? Well, if you knew, hopefully if you knew you weren't in here, because that's what I'm going over. Move over the item. You can select it if you want. There. Now I've got the whole thing selected. You can select just the label and move that, but let's get the whole component. Or if I'm clicking over here to unselect everything, move on top of it, and then I hit M. Now I'm in move mode. You can see the cursor has the little up, down, side arrows, and the symbol I was on top of is being moved right now. So that's all well and good, so I can position it, say if I want it to go along here, except I don't want it pointing at my battery. I want it kind of going the other way. Hit R to rotate it. So while it's being moved, and by the way, once I started the move, I'm not holding anything. I'm just moving the mouse. Really easy, low stress on your fingers. It makes it handy. Okay, so when I clicked again to place it. So now I have it looking better. It's along this line, which doesn't really mean anything, but it might. If I set my grids up, which is an advanced thing, you could set all sorts of things on your grids. I'm going to ignore that for now, because we'll just go with some of the defaults. Then now let me click on that circle, pull up, over, click there, click in this circle. Yeah, I've got a wire. Of course, I want to actually connect it up to my battery all the way. There's a circuit. Am I done? Anyone see a problem with my circuit? Oh, yes, I need a resistor. I wanted to point that out because an LED is one of the simplest circuits that, anyway, you give it to your 8-year-old, they want to make a circuit. LED is perfect for that, but you have to know to put a resistor on it. Okay, so I need a resistor. What am I going to do? I'm going to hit A to add. I'm going to just type, hopefully not typo it. Thermistor, is it? Oh, just so many, as you can see, there's so many options in here. Like if you know the type of component you're looking for, you can find its name, you could type that in to search for. As you can see, there's so many different options, but I'm just going for the simple R. It's a resistor. Hopefully they'll do it. But you know what? I don't like that one, because that's not what I'm used to for a resistor. Oh, look, RUS, which is the ANSI standard zigzag. Okay, that I'm comfortable with. So you can pick, they have some options in there in the libraries. They have you covered, whichever one you want to prefer. So I'll go with that. Now it's moving. I haven't clicked yet. And I realize now I can either put it here or here. I'll put it up here. So I want to rotate it, hit R. Oh, I'm not sure of the most efficient way to do that yet. It's an advanced thing. So I'll move that wire away, hit M to move this down, yeah, right about there. Then I'll connect its wires up by clicking in the circles, moving it over. There, am I done? No. I picked a generic resistor. I double click on it. I'm getting the text value because I double clicked on I double clicked on the label. You can change the label. This label, maybe it's R7 by this point. Sure, change it. But I want to change the resistor itself. So I'll do that again. Go to the middle of the symbol where if I click on it, it selects all of it. And just double click there. Now I get some bigger things. More choices. Yeah. Ooh, advanced thing. He wants to get the right resistor. We need to know the voltage on the battery and go from there. Well, we could do that. I'm going to ignore that for now. But, sorry. I was just wanted to show, also, you can move over to an item, right-click on it, and you'll get a pop-up menu, which gives you a lot of attributes, including exclude from simulation, bill of materials, board. If those don't make sense to you for now, ignore them. Later, you'll probably recognize more. And we're going to skip this for the moment, just trying to get straight to the simplest. But, one of the things maybe is helpful is if I add some power. So if I hit the letter P, it's going to want to place a power item. I can open that up. And here is where I can specify something about a specific voltage, do this. But I'm not quite to that point yet, because I don't know what resistors, what battery, what LED I have. I don't know. VCC. That's a general one. To say, yeah, this part of the circuit is where power is coming in. And then let me hit P again. And then the other thing I know I need is a ground. So if I want to designate this well, I do a ground and say, okay, this part. And I know this is the source power because the plus on the battery symbol tells me. So kind of give it the right thing. And if you see, since I'm still in the adding mode, to place a symbol, it keeps popping that up. So until I hit escape. Now I can click anywhere else. So in theory, this, other than the specific values for the battery and the resistor and whatever else, this is in general one of the simplest circuits you can do. No switch, no fanciness, no states changes there. So then let's look at what some of the options across the top are. Navigation for viewing, back, forward, you can mirror, rotate. Symbol editor, if you know what you're doing and you need to get your symbol and it's not already in the library. Symbol library browser, so you can do advanced stuff and pull in more. Footprint editor, if you need a footprint, which we're going to look at soon. Annotations. Electrical rules checker. This is the handy one. This is the simulator in here. Simulator and rules checker, these two. The simulator might be a little more advanced, but the rules checker will give you some basics. Run ERC. input power pin not driven by output power. So, and you see here, it doesn't like what's going on here and what's going on here. It put these little markers on. So not only does it tell me, oh, there's something going on there, it says, oh, right here. And I can select which one, where the problem is. So that will help you if you want to check and find out what's going on your system. I'm going to delete all markers and just ignore that for now. Some of the tutorials we'll cover, and there's another power symbol you used to have to put in. But again, this is version 9, just came out, I believe February 20th was the official release. So just as I was thought I was done and all set with practicing and examples, boom, they put out a new version. So I had to uninstall the old one and put in the new one. No, but given that, so the general flow is you run this checker. You can run the simulator if you want to get some advanced things happening, the SPICE simulator. And by the way, if I check my desktop environment here, these are showing up as separate windows, separate programs. So this is kind of the aspect of the suite going on here. And if I hit Alt-Tab, I can go between all these. Oops. And where this, so know about the simulator, look up a little quick tutorial on just that if it's something you might want, but that's not a first thing you should do. Next thing you might want to do though is go to the PCB editor, which is this green with lines in gold. I click that. Yay, I'm in an editor. Now what? It's kind of all dark and faded out in the background, hard to see, because there's nothing there yet. So up here, there's a switch to schematic editor button. Oh, okay. I'm back here. I know my circuit. Here, there's nothing. What happened? I thought I made a circuit. You want to come back over here, update PCB from schematic. I've got errors. I don't care. Do it. Yeah. Nope, those were fatal errors. Oh, it says it can't do anything. Why? Because again, I got errors, I close it, I'm not seeing anything. Why? Let me try again. Let me actually look at the errors this time. Oh, no footprints assigned. So it doesn't know what those should look like. I had picked the generic entries intentionally so that they don't already have footprints associated. So we can go back and say, oh, if you have that happen, what do you do? Right under here. Or there's assign footprints under tools, which took, if you saw, it took me a minute to find and drill down and everything. Guess what? That's a common thing. What's right here? Assign footprints. And if you can't tell from the distance, the icon is the symbol and the little chip footprint kind of icon together. So there's the symbol icon plus the other icon. There you go. Now I can fix a few things. So what I see here is the footprint libraries on the left, my symbols that I've used, battery, resistor, and LED, here in the center, and then filtered footprints. So if I click the battery, I don't know, but let me try. If I say battery in the search box, or just the first 3 letters. Make this a little bigger so I can see out. Oh, wow. Look at all these different batteries holders, all sorts of kinds. Panasonic. Let's try this CR1225. Okay, so I've assigned something. Should I check if it worked? Yeah, let's see. So again, I switch to the PCB editor, then I go to update from PCB. Update. Oh, still have errors. I guess I should look at those errors again. Oh, 2 more. No footprint, so it can't do anything. Okay, I guess I got to go back and fix that too. So again, let's see. Assign. So for the LED, let me just add in the search box. LED. Now, most likely, when you're doing this for real, you'll have something, a specific LED already, not just generic, I want a place order, unless you were doing a high-level design of your circuit and now you're trying to do it concretely, which is, I was doing very high level. So I'm looking at these and I'm seeing a whole bunch of SMD, which is surface mount, which I know I personally don't want to try to mess with. This isn't the simple way to, you can do that yourself, but it's hardware. And then THT, through hole. So let's try this one. See if it works. Oh wait, I forgot, while I was there, LED, and there's all sorts of oh, wait a minute. Here's a simpler one. I'll go with this 3mm. Sure. Double click on it to assign it. Ah, that's why it disappeared. And then this resistor. Ooh, lots of resistors, and again, a whole bunch of surface mount components, which I don't want to be using. An array, nah. Axial. I don't know. I don't know what anyone's favorite resistors are, and it will be what you have on hand. So if I come back here now and update PCB, ooh, I had more problems there with the specific ones. Some battery issues. So this is where I'm going to come into this one I pre-made. So we can see, so now this is one I tested to make sure I have things that work. So here a Panasonic CR2032, very common battery. This LED, which is maybe tricky. I did pick an SMD. Just for variety and through hole. So this circuit, which is pretty much what I just did, showed you how to get to. Let's come over to the PCB editor, import, update PCB, and at this point, no errors, no warnings. Because I picked these that have no problems. By the way, if I go back to semantic and look over here, we're going to have the check. And we just have those two issues that were flagged before, ignorable. PCB, here you go. And then if we look at what I have here, I've also put a couple holes in my board, just for mounting holes. Now, once you have things laid out, and I've drawn the wires between the components, so I have an LED, a resistor, and the coin battery. Then, if we come over to the 3D viewer, which is this icon over here, a couple over. So right next to update PCB from the schematic is 3D viewer. Doesn't look that much different, except you can grab it and rotate it. So now you can say, oh, okay, that's what my circuit looks like. And for a simple circuit, sure, that looks like it's enough. So let me close the 3D viewer. And now at this point, you could export the proper files to send to a service bureau to print, or to have manufactured, sorry, not print, I'm 3D printing thinking. And if I check the main app, go into the plugin and content, oh, good, it connected this time. Depends where I am. But you go to the main interface, you go to the plugins and content manager. Oops. Let me drag it taller and bigger. Allows you to do several things. There's a lot of plugins you can get by default. You can add more sources for your plugins. But what I wanted to highlight here first is what fabrication plugins. And at the moment, by default, Connect Up Live, I get 8 different manufacturer fabrication plugins. PCBWay, Sierra, HQ PCB, NextP. So these are all companies, you send them the files, they'll make the board and send it back to you. And there are extensions here in KiCad to make it easy to just pull it over and do that. So if you're looking at a manufacturer place, this is probably one of the simplest ways to make it happen. Gerber files tells it how it's going to make this board itself. There's some other files you can do, and you can even have them place the components and everything else if you want. So we're showing that so that you know you can do that. So file, you can always export. Under export, there's also fabrication outputs. So you can do Gerber drill files, so you can get your holes in your PCB correct. Bunch of others, bill of materials. But what I care about now is CAD. Export, I can export this as a CAD file. Step, I know step. So let me give this a weird name. Foo.step. Success. Yay. So I'll close that. And then I'm going to pull up FreeCAD. Is anyone here familiar with FreeCAD? Quarter of you. You want to. It will get you going quickly, but you can do, I do all sorts of 3D printed designs and other stuff with it. But let me say new and scrunch down here a little. Get this a little over. Okay, file, import, and my test. Hello project, foo. There we go. So it's a standard CAD file you can bring into any standard CAD program. And then once I have it here, by the way, it's handy because it actually exports these components individually, so I can hide it if I don't want to be looking at it. But now, let me see if I can speed run something. Make a body. Oh, wait a minute. Okay. I had something selected when I did that. I'll just ignore that. Let me do a sketch. XY plane. Rectangle? Okay. Close. Oops. I'm bumping it down a couple millimeters. Oh, wait a minute. I'm down a couple millimeters. There we go. Use the negative. Then in FreeCAD, I pad this. I've got a block. That doesn't look so helpful. Select this. Oh, wait a minute. Say OK. Select this. Say thickness. Oh, and I just hollowed it out. There. I've got a case. Well, almost. Let me do another XY plane sketch. Yeah, close enough. And my holes are rough, so, oops. This is not a FreeCAD session, or tutorial, so I'm not worried about that. But I am just showing one thing, is that when I made these holes in my circuit board, I did not measure and place them. I just randomly dropped them. So they're not all even. That is why I could bring it, as an illustration, I could bring it into my CAD program, see where those holes are, and then fix it this way. And then sketch. -2, and then if I pick that sketch and then pad it, there we go, I've got posts in the right place. So by exporting my circuit board design from KiCad, I can bring it into any other CAD program and design a case to go around it and have it physically referenced there so I could see, oh yeah, it's there, and let me put the chip back, or the resistor back. So I can see, oh, that is the right place, the right things, do the right cutouts, and do all this, and then 3D print this. And then there's a secret. Remember I mentioned those 8 different fabrication plugins so that those different manufacturers will manufacture your PCB board for you? Several of them also do 3D printing. So you send them the step file from the CAD that you just did of the case, they'll make the case and send that back to you too. So, I mean, it's simple. I mean, you as long as you pick the right symbols, of course, and everything, and then, oh, check your rules. Like checking my design rules here for the PCB. Wow, shocking. I didn't break any rules. This might work. And a manufacturer might have different rules, or you might set up different rules for different projects. That, again, that all should get you going in tutorials so that you can go to a tutorial on YouTube or anywhere else, walk through it, and have a chance of actually pulling it off. But I say, KiCad makes it so easy, though. If you want to design a circuit, it's easy. If you want to lay it out, it's easy. If you want a professional company to manufacture it for you, it's easy. And I think ballpark, I was seeing some that like $5 to make a one-off circuit board and send it back to you. I remember when it used to be 10 times that. So I have not even gone comparison shopping and pricing and saying, oh, if I get 3 of them or 5 of them, is it cheaper or more or less? Or, you know, you can get deals and coupons and whatever else. So hopefully that tells you how to get going with KiCad. And by the way, yes, here is in this project I did previously to make sure it work. I export GBR or Gerber files. So it does all these different, the silk screen, paste, cut mask, copper, all this. Then drill files so that it knows how to drill the holes. I mean, I didn't have to know any of that. KiCad did it for me. So if in theory, I just take these files, put them in a zip, send them off to the company, send them $5, I get my board back in the mail in pretty quick. But again, remember, help and getting started with KiCad. Oh, that's help. Getting started in KiCad. That's what you want to do. That's what you want to step to next. And then go and make something. Okay. Any questions? Oh, are there plugins? Yes, there are. They have several sources, and then other plugins you can bring in directly from whoever published them.
Are there any plugins that automatically submit it for fabrication?
Yes, some of them do. Yep.
Just a quick question. Do the manufacturers that you send the PCB board plans to usually give you quotes, or is it kind of like a flat rate for just like the general size of the PC board?
Do they give you quotes, or is it? Yeah, no, it's quotes. It's by details, and if you do multiple circuits, on there, they might charge you for individual boards, even though it's physically one board. Different things like that. So it's per manufacturer. They have their own rules and their own design.
Have you had any experience with like the auto layout or like optimization tools? Like obviously you had a pretty sparse design. Is there a way to tell it, oh, I want to shrink that into a smaller footprint or something like that?
I personally have not had any experience with the auto layout tools because I haven't hit that speed yet. I'm mostly doing stuff on breadboards. For one-off projects, I use these little ones. And by the way, after the talk, I've got some, if you want a breadboard, I've got spares here to remind you to do something with it. But yeah, no, they have plugins that do various optimizations and layouts, and also checking that will tell you about various things, including RF checking, which I'm not up to doing circuits with RF sensitivity yet. Okay. Any other question?
Do you know if there's any work being done on like using Gen AI in order to even be smarter about that type of optimization?
Asking if there's AI. From being
Or
a
machine
software
learning in general.
from being a software developer and seeing what AI does for software, especially because I'm a security company person, so I work in a security company doing security software. Always have to check what it does. However, I will say the layout and patterns and designs like this are easier for AI to get right than software itself is. But I've not checked the state of the current AI on that.
Thank you.
Okay, well, thank you very much.